Hello, my name is Lucas. I'm a PhD student at the University of Waterloo, and I've been working under the supervision of Professor Bruce Hellinger. So, in our research, we've been exploring some cost-effective methodologies for estimating pedestrian exposure and pedestrian risk, and this work is the first product of our research and is entitled as Comparing Direct Demand Models for Estimating Pedestrian Volumes at Intersections and their Spatial Transferability to Other Jurisdictions. Let me provide you a bit of the context of this work. So, the support for the use of active transportation modes such as cycling and walking has been increasing over the past few decades. So there is a need for municipalities to develop strategies to focus on this type of road users. And some of these strategies, like the development of safety analysis or site selection for design or operational improvements, requires that an exposure is known for the entire jurisdiction. So in this work, we are focusing on estimating pedestrian exposure for all jurisdictions, okay? And the level of aggregation that we are interested in is the signalized intersection one. And the variable that we are looking for is the annual average daily pedestrian traffic, or the AADPT for signalized intersections. There are a few techniques and tools that are very useful for estimating pedestrian exposure for entire jurisdictions. The first one is the short-term counts, or the STCs, that are usually collected over the course of one or more weekdays and usually during an 8-hour period. Okay. The second type of information is the continuous counts. There are usually permanent count stations that provide long-term information, and in sites that have this kind of stations, the ADPT can be directly calculated, and also if we have a reasonable amount of continuous count stations, uh, it allows the development of expansion factors, so we can convert the short-term counts to ADPT. The third, the two, there is this tool. There is a very useful for also for estimating the ADPT for entire jurisdictions, which is the direct demand models. So basically, this is a model where the dependent variable is the ADPT, and the independent variables are land use, socioeconomic features, and it is really useful for estimating the ADPT at sites where no pedestrian information is available. So one would take the ADPT for the sites where there is this information and would associate it with land use and socioeconomic uh, data. So the ADPT can be estimated for sites where no information is available based on information of land use and socioeconomics that is usually available for jurisdictions. Some jurisdictions lack pedestrian data to directly estimate ADPT for the entire jurisdiction and to develop their own direct demand model. So the main objective of this research is to evaluate if the direct demand models that were developed in other jurisdictions, if they can be transferred to other jurisdictions. So here are the specific objectives. The first one is to identify direct demand models from the literature. The second one is to qualitatively assess or compare them. And the third one is to quantitatively assess the spatial transferability of the direct demand models. Methodology. The first step is a literature review step, where we identify some of the state-of-the-art direct demand models and also identify the independent variables, the model structure, and the model coefficients. Okay. The second step is to apply these models to another jurisdiction. So for this, we need to collect the independent variables that are in the original model for another jurisdiction. So then we can estimate the ADPT for the sites that we have the information. Just to provide a notion of the types of variable that are usually seen in these type of direct demand models. We have basically three categories of variables. The first one is census based, like population density, employment density, household income. We also have land use features like commercial places, presence of school, and geometry and operational features like presence of transit stops or the sidewalk length. Okay. And for selecting the sites, we have two criteria. We only select sites where continuous count stations were available. So we selected sites that pedestrian counts are available for at least 30 days, and we also use periods that are unaffected by COVID-19. Step of the methodology is basically quantify the accuracy of the transferability. So we have the true ADPT that we can calculate it from the data that we have, and we also have the estimated ADPT from the model developed in other jurisdiction. So we basically compare the true and the estimated ADPTs, and we selected six models in the literature and applied them to three different jurisdictions. We investigated approximately 20 to 25 direct demand models, and we ended up with the selection of these six models, basically because they comprise a range of different sample sizes for calibration. So we have sites that use 1.5K sites for calibration, but we also have sites that use 44 sites. Okay. Um, we have different models in terms of complexity, in terms of the number of independent variables that was used, and we also have different level of pedestrian exposure, which is what we use the average ADPT to represent the level of pedestrian exposure. We applied these models to three different jurisdictions. Two of them are located in Ontario, Canada. They are Milton and Toronto. And another jurisdiction is Pima County, which is located in Arizona, United States. So I would like to point out that these three jurisdictions are very different in terms of pedestrian activity. So for example, Milton, we have an average ADPT of 300, approximately 300. For Pima, we have an average ADPT of 28, and for Toronto, we have 23,000. So very different levels of pedestrian activity. And here is the sample size for each of the jurisdiction. And I would like to point out that the sites that we use in Toronto are located in downtown Toronto. So this is a very unique and specific environment where we have a lot of employment. The high density of employments and the non-motorized trips is very intense in this area. So this is a very peculiar environment. A little bit more details on the jurisdictions. Here we have the population density, okay, for the three jurisdictions. We can see that there is a very different levels in the three jurisdictions, as I mentioned before. And I would like to point out that these three dashed lines represent the maximum, the average, and the minimum value of the original calibration data set. Okay, so we can see that the Toronto sites are out of this range. And here we have another example. This is the number of transit stops. And we observe this kind of pattern in almost all of the variables. So we have a Milton that has a kind of a middle pedestrian activity. Pima County has a very low, and downtown Toronto has a very high pedestrian activity. And as I mentioned, for some variables, the Toronto was outside of the original calibration range, which, which is could be a problem, and it was a problem that we identified when we tried to transfer the models to Toronto. Here we have the results. This first table summarizes the original model development. Okay, so here we have the 6 direct demand models that we selected. We have the mean average error for each of the studies when available. And here we have the indicator that we are using in this work, which is the relationship between the ratio between the MAE divided by the average ADPT. Okay, so we have this information. We also have the MAPE for one of the for one study. And just to point out that the kind of the desired accuracy that we are looking for is a ratio of MAE over ADPT of between 0.6 and 0.65. So this is the metric that we are looking for. For Newton, we observed a very reasonable and good performance among all models, except for the model of Sanders. Okay, so we have here Sanders, and it was expected because Sanders use only 3 independent variables. Okay, and I would like to point out that Milton shares characteristics with the calibration jurisdictions, as we saw before, and it has like comparable pedestrian activity and land use attributes, and that's why we believe that the transferability was adequate for Milton. A bit more detail on the Milton transferability. Here we have 2 scatter plots where the x-axis is the observed ADPT and the y-axis is the ADPT that was estimated by the direct demand model. So I would like to point out to these 5 sites here that we observed a systematically underestimation by the models, and we did a detailed investigation on these sites, and we noticed that they were associated with the presence of schools. So probably this is indicative that a school in Milton generates more pedestrian activity than in California, which is where Griswold was developed, and in Utah, where the model of Singleton was developed. The result for Pima, we observed a poor performance among all models, except for the model of Schneider. Okay, we have a reasonable transferability. Despite the reduced potential of pedestrian trip generation, where we demonstrated in the evaluation of the explanatory variables, overestimation is still observed. So in Pima County, we have an average ADPT of 28, but when we check the average ADPT for the replications, there is overestimation in all of them. Okay. And we believe that happens because a different relationship exists between the number of trips and the land use and socioeconomics in Pima and comparing to the other jurisdictions. So basically the model coefficients are probably different in Pima than they are in the original models. Here we have Toronto. We observed a poor performance among all models, except for the model of Singleton that presented a reasonable result. And as I mentioned before, these sites are in downtown Toronto, so this is a peculiar environment with extremely high employment density and a lot of non-motorized trips. So that's why we believe this transferability was not adequate. Are the conclusions. We discovered that while some of the models performed acceptably well when applied to other jurisdictions, there was no one single direct demand model that performed well across all the three jurisdictions. We observed a good performance in Milton, and this is a very interesting finding because Milton shares characteristics with many suburban US and Canadian jurisdictions. So it shows the potential of transferring the direct demand models to other jurisdictions, especially those one that shares characteristics with the original calibration, with the original jurisdiction of the models. And we also observed a poor performance in Pima and downtown Toronto. And as we discussed before, probably because the sites that were analyzed present very different characteristics than the one that were used in the original models. And for future work, there is a clear need to develop methods for improving the spatial transferability of direct demand models, which is also part of our research. Listening. If you have any questions, please feel free to reach out to me. Here is my contact information. So thank you. Cheers.